Okay guys, this is going to be the second video on the urinary system, and so we're going to talk about the part of the kidney that does the lion's share of the work, which is the nephron. This is what's called your functional unit of the kidney, and the function it's carrying out really is filtration. So there are two general parts to the nephron, so we're going to talk about each part and its individual contribution to the filtration process. So you have the glomerulus, and then you have the renal tubule. All right, so each of these different areas, first the glomerulus and then the renal tubule, is going to carry out different functions of the nephron. The glomerulus is going to take care of what's called bulk filtration. And I'm going to kind of explain this with an analogy in a minute. And then the renal tubule carries out two processes that are important. It carries out reabsorption and secretion. All right. So we're going to use our analogy for a minute. When we're talking about the function of the nephron, it's kind of like this. You have a whole bunch of clothes in your closet, right? And you want to kind of look at what you have, assess what you have, keep some things and get rid of some things. The way that it works in your nephron is like this. We're going to take everything out of the closet, and then we're going to put it into two piles once we get into the renal tubule. One pile is what we're going to keep, and what pile is what we're going to chuck, okay? The part we're going to keep is what's being reabsorbed. What I mean by reabsorbed is it's going right back into your circulatory system. You're keeping it, you're not getting rid of it. The stuff we put in the bag to go to Goodwill, that's secretion. That's what you're chucking, and that's what's going to leave the body essentially as part of your urine stream. Okay, so we're taking everything out, sorting it, and then what we're keeping is being reabsorbed, what we're chucking is being secreted, and then eventually excreted as part of urine. Okay. In your kidney, to accomplish this, because mind you, you've got to do this with a little bit of blood at a time. You can't take all the blood you have, pump it into the kidney, clean it all up, and put it back. You can't do it that way. You would lose blood volume everywhere else, of course, right? So to conserve blood pressure, we have to make sure that we're doing this little bits at a time. So to accomplish this job on a very large scale, your kidneys have many, many nephrons. So they'll have a million nephrons per kidney, filtering just a little bit of blood at a time. Eventually, all the blood you have is going to make it through the filtration system several times a day. So I'm going to draw an absolutely terrible picture of what this looks like. So my students who know me know that I can't draw worth a damn. Okay. Okay. So let me just add color so we can see all this different stuff. All right, so a nephron is divided, as I said, into two general areas. You have the glomerulus, okay, and then you have this tubule, and then the tubule is subdivided into parts as well, so we'll talk about that in a second. Okay, and I'm just going to draw off the last piece of this. Okay, and I've kind of flattened the tubule out. In your nephron, it's actually quite twisted and convoluted, but I flattened it out to keep it simple. All right, so we're going to have blood coming in and then blood going back out. Blood coming into the nephron is coming in through a structure called the afferent arteriole. Blood leaving the nephron here, that's going to leave through a structure called the efferent arteriole. And the terms afferent and efferent simply mean going towards and moving away from. Okay, the structure in red, as it looks like a tangled ball of yarn, that's a tangle of capillaries called the glomerulus. This is going to take care of bulk filtration. Almost like you're passing something through a sieve when you're draining it. So what's going to happen is blood's going to come in and go through this filtration system. Some blood is going to exit right back out, and then some is going to pass into the tubule. Once it passes into the tubule, it is officially called filtrate. Okay, it's not blood anymore. Well, it's not that it's not blood, it's been filtered. Then we're going to move into the parts of the actual renal tubule. Just for some context, the renal tubule is about an inch and a half long, so it's not that big. All right, so this first section, which I'll just mark off, 1, 2, 3, 4. Section number 1 is called the PCT, proximal convoluted tubule. Section 2 is called the descending loop of Henle, which is a fantastic name. You're going to loop around and then you're going to head back up. Number 3 is the ascending loop of Henle. So we're going to descend down, right? Then you're going to turn on the loop and ascend back up. And then the fourth area is called the DCT, the distal convoluted tubule. So we remember the terms from AMP1, proximal and distal. Proximal means close to, essentially, and distal means further away from an attachment point. So this is proximal to the glomerulus, this is distal to the glomerulus. Okay. Once the filtrate moves into the nephron tubule, now we're going to carry out both reabsorption and secretion. Most reabsorption and secretion takes place in the proximal convoluted tubule, and the reason for that is the PCT is designed, the cells of it, while it's all simple cuboidal epithelium, specifically in the PCT, attached to the membrane of those cells, right, those extensions, there's abundant microvilli. That largely increases the surface area of the proximal convoluted tubule so that you can maximize reabsorption and secretion in that space. So you're going to have a lot of stuff that's passing into and out of this part of the tubule. Things get a little more simplified when we get into the loop of Henle, but this is going to give us the ability to concentrate our urine, which is very important because we like living on land and we don't want to dehydrate. And then on the fourth area, the distal convoluted tubule is giving us some last opportunities to make choices about what we keep and what we get rid of. Finally, you're going to move into this area, which is the collecting duct. The collecting duct is almost like when you take out the trash and then you find like a gum wrapper in your pocket and you kind of pull it out last minute and throw it in. This is where you can make any final decisions about what's going to be retained and reabsorbed versus what's eventually going to leave the body as urine. Once you hit the collecting duct, it's urine, okay? So I'm going to draw some in and out arrows. If something is going this way out, that means we're reabsorbing it. If something is going this way in, that means we are going to secrete it and it's going to be part of our urine stream. So we have two things that could potentially be secreted here. You have hydrogen ions and we have ammonia, which I had told you was one of our forms, right, of nitrogenous waste. Things that we are going to reabsorb here. Okay, so things we could keep back. First off, we have bicarbonate. This is going to be important for control over pH. Sodium, water, nutrients. We shouldn't be getting rid of nutrients. We love them. We need them. Why would you get rid of nutrients? You wouldn't want to. Why would you want to dump glucose out in your urine stream, right? You want to make sure that you have the potential to keep it because you need it. And then potassium. All right, so let's talk about why we're doing all this craziness right here. So if you look at this carefully, it makes absolute and complete sense. So you want to reabsorb, if you need it, sodium and potassium. Those are two electrolytes we absolutely need to run the heart and run the nervous system. You're reabsorbing water here. Again, we want to make sure that we have a lot of avenues to reabsorb water. The goal here is we want to prevent dehydration. And then nutrients. There's no reason you would want to throw out protein or sugar or fats or any nutrient, right? You don't want that to wind up in your urine stream because it's potentially usable. If we find nutrients in our urine stream, that usually indicates there's a problem. What we can get rid of is some hydrogen ions that's going to help regulate the pH of your blood. By getting them out of the blood, we're going to take our blood from a more acidic to more basic state. And ammonia, which we already identified, was a nitrogenous waste and had to go anyway. Okay. When we go down the descending limb of the loop of Henle, what we're going to reabsorb is some water. This is going to give us the ability to concentrate our urine if we need to. So we're going to extract water from the urine and leave the solute staying put in the tubule. This gives us the opportunity to concentrate urine in the event that you're not drinking enough during the day. On this side of the house, we have the opportunity to reabsorb sodium. And again, this is all about adjusting concentration of the urine. This also provides a very salty environment in our peritubular capillaries that are going to surround this piece that can pull out water later on in the system should we need to do that. When you get to the distal convoluted tubule, we have another opportunity to make some adjustments. So we can pick up things like, once again, sodium. And once again, water as we need it. And again, bicarbonate, right? So bicarbonate, again, we can use that as a buffer in our bloodstream, and we can make some adjustments to pH. So between changing the amount of hydrogen ion that we either keep or get rid of and the amount of bicarbonate that we keep or get rid of, this can help make adjustments to the pH of your blood so that what we don't need really does truly wind up out in the urine stream, but your blood pH is where it needs to be. Let me just make sure I got my colors right. Okay, here we can also get rid of some hydrogen ions as well. Again, this is all about adjusting the blood pH. So you see you have a couple of opportunities to reabsorb or secrete hydrogen ions and bicarbonate. So that's going to give you the ability to have really good control over your blood's pH. Again, so important. And then the last piece is we're going to get here. We have, again, the opportunity to reabsorb sodium. This is really going to concentrate the fluid in the peritubular capillaries that are overlaying the space. And by doing that, that gives us the ability to draw out even more water. Okay? Why do we want to maximize the ability to reabsorb water? Because we want to prevent dehydration. It's fine for any of us. If your urine changes its composition a little bit, I'm okay with that from a water or a sodium perspective. What we need to make sure we're focusing on is that your pH, osmoregularity is conserved. You want your fluids to be balanced, and you want your electrolytes to be balanced internally. What goes out as waste as far as I'm concerned. Okay? So yes, this is super busy, but what you should get appreciation for this is that different parts of this renal tubule have very different jobs in terms of controlling either electrolyte level, fluid level, or pH. Okay. Our next video, we're going to talk about how your kidneys work to control blood pressure.